Okay, once again, 1, 2, 3. Okay, Assalamualaikum dan selamat petang. Salam Malaysia pada ni. Saya Akasha Arshad. So hari ini kita ada online coaching klinik bersama Encik Vincent dan juga Encik Kuan dan juga let me see Encik Aswin dan juga Puan Mas lah. So, terima kasih kepada semua yang hadir pada hari ini. Sebelum kita mula, saya minta bantuan tuan-tuan dan puan-puan dan juga pelajar-pelajar yang baru saja, mungkin ada yang saja baru habis kelas. So, saya mohon sharekan YouTube live ni kepada grup-grup WhatsApp, grup Telegram dan grup-grup media sok yang ada supaya kita dapat orang kata penonton yang banyaklah pada hari ini. So tujuan kita pada hari ini adalah untuk orang kata nak buat sedikit recap lah. Selepas minggu kami pihak urus setia memberi peluang pada peserta-peserta POLYCC LOL 2024 untuk biasakan dirilah dengan web console ataupun AWS SageMaker dan juga modul LOL untuk leaderboard tu. So saya rasa I'm sure that you have a lot of question today. So nanti Encik Vincent akan berikan tip-tip dan best practice lah bagaimana untuk menang POLYCC LOL 2024. So suka saya nak ingatkan tempoh pertandingan POLYCC LOL 2024 peringkat saringan ni berlangsung daripada 13 Ogos sehingga 3 September. Dan selepas 3 September kita akan pilih 5-6 finalis untuk kita bawa ke peringkat final, di mana pertandingan peringkat final ataupun peringkat akhir akan berlangsung di Dewan Zabar KPT pada 23 September. Okey. Jadi seperti mana lagi sekali saya minta mohon peserta yang online pada hari ini, pada petang ini dekat Putrajaya hujan Kalau kat Singapura saya tak tahulah, nanti Encik Vincent akan bagi tahulah. So boleh scan, boleh yang belum tu boleh share, subscribe and like channel EduTV at POLYCC. So jadi selepas seminggu kita ada 232 tim yang telah submit model, maksudnya telah melakukan training lah. Setelah menggunakan 30 jam hours, 30 hours training hours yang telah diberikan oleh pihak urus setia. So saya harap peserta-peserta terus akan melakukan atau melaksanakan training lah. Mungkin ada beberapa orang kata ada yang tak faham. So itulah tujuan pada hari ini, kita ada online coaching klinik. So kita akan bantulah pada peserta kan. Saya rasa mungkin banyak soalan pada hari ini. Okey, jadi bagi baki itulah saya suka nak remind lah. Mohon semua orang kata mengambil peluang ni lah untuk belajar LLM kan. Kat mana lagi kita nak belajar. So kita ada peluang ni di pertandingan POLYCC LOL 2024 dan pihak urus setia iaitu BIPD mengharapkan semua pelajar dan pesyarah yang telah mendaftar supaya mengambil peluang ini untuk mengambil ilmu lah, belajar ilmu mengenai untuk pembangunan LLM, iaitu otak bagi ChatGPT. Bukan ChatGPT, maksudnya untuk Gemini, Siri. So semua menggunakan LLM ini. Jadi saya suka lagi untuk remind bahawa kita tema pada hari ini, tema pada pertandingan peringkat saringan ni kita ada tema dan tema kita adalah TVET di Politeknik dan College Community. So tema kita ialah di POLYCC. Tu keyword tu kena ingat tu, keyword tu POLYCC. So keyword POLYCC ni kena orang kata terpahat ataupun kena ingatlah masa kita buat dataset tu. Dan juga kita ada subtopik TVET di dalam education, TVET policy, TVET orang kata aktiviti pelajar dalam TVET, TVET Madani dan TVET dan Revolusi Industri 4.0. So semua subtopik ni kita kena pastikan dia ada dalam dataset kita. Jadi kalau ingin tahu lebih mendalam, saya rasa Encik Vincent akan terangkan. Kat sini saya ada juga sediakan beberapa kata YouTube video yang ada 5 minit, ada 4 minit, ada 9 minit. Semua step ni dia berdasarkan PDF yang telah dibangunkan oleh Mr. Vincent. Mungkin kalau nak tengok YouTube, bolehlah tengok playlist tips nak menang POLYCC LOL 2024. So boleh scan lah QR code, nanti saya akan share jugalah slide ni. Dan juga kita pun nak remind bahawa CJ Pernyataan dan CJ Perhargaan bagi POLYCC LOL 2024 peringkat saringan ni, kalau nak CJ, saya mengharapkan dapat kerjasama lah daripada peserta supaya sekurang-kurang 15 jam lah digunakan dan telah membuat submission ke leaderboard supaya kita memanfaatkan peluang ni lah untuk belajar LLM ni. So 15 jam lah sekurang-kurangnya. Kita boleh tengok pihak universiti boleh tengok. So saya harap semua boleh ambil peluang ni. So last slide Mr. Vincent is the most important one untuk bagi motivasi sikitlah kepada peserta, participant. So kita ada hadiah. Mungkin saya rasa slide ni rasanya orang kata terlepas pandang. Mungkin video kita pun ada bahagian part 1 and part 2. So mungkin panjang, mungkin orang kata tak perasan. So di sini saya nak remind bahawa kita ada hadiah. Yang pertama RM3,000, kedua RM2,000, ketiga RM1,000 dan sagawati RM500 lah. So saya harap ini akan membakar semangat peserta dan mengambil peluang untuk belajar tentang LLM. So bila orang tanya apa itu LLM, saya harap peserta-peserta LOL 2024 boleh explain dengan detail lah bagaimana kita buat training, macam mana kita buat configuration pada hyperparameter tu. So Encik Vincent, tanpa melengahkan masa, saya hands over to you Mr. Vincent to take it from here. Okay Mr. Vincent, you have the floor.
Sure, thanks Akasha. And so hi everyone, very exciting. Thanks for all the participation. We have a very heated competition. We have like 200 over group submission onto a leaderboard already. And we see that the top win rate right now is still being held by POLYCC. Very, very closely behind, we have other teams and groups chasing behind for the top core positions. So I believe one of the things that everyone has to ask is on how you can improve your win rate. But before that, maybe we can take questions on the floor. So if you have any questions, just feel free to put it on the chat so we can answer that as we come along. So if you have any questions, do drop your questions on the YouTube live link so we can answer them as we begin to go along, because we have like 71 of us here streaming in. It's going to be hard to get everyone to unmute to talk. So while you are putting your questions, I'm going to share a few tips first. So first thing is that how can you improve your model's data set? So let me just share my screen again very quickly. As if you have any questions, continue to drop them on the YouTube link, and then we will happy to take them over the next 45 minutes. So you saw earlier from what Akasha mentioned. So essentially, you have the competition, you are competing on TVET, right? So the first tip you want to know is to be aware of is that you want to prepare data set that is related to TVET POLYCC information. So the questions that we have within the leaderboard, they are all TVET related. So the idea is that if you prepare data on information that is not related to TVET or not within these 5 subdomains, then you are training your model on something that is not exactly related. So you want to prepare your data set along the lines of TVET POLYCC and specifically on things like education, TVET policy, student activities. These are some of the actual sample questions that actually the leaderboard will ask your model when you submit your model to a leaderboard. So this will give you an idea what are the kind of questions that your model need to be able to answer. Under each of the subdomains, there's about 10 questions. So you add it up together, there's about a total of 10 times 5, about 50 questions that we ask on each of your model. Right, so that's the first thing. You want to train your model and fine-tune your model on the correct domain. Now, the second thing is that how do you then get the win rate to be up? So is to be aware of what is the rubric. So when it comes to the competition, for the virtual leaderboard that we're looking at right now, essentially it's on two main things. So first, of course, your answer got to be accurate. You should be training a model with factual information. That's number one, accuracy. But second thing, which is the one that accuracy is normally quite not the hard part. The one that people struggle with is around comprehensiveness. And by that, we mean how good your model it is when it's answering a question. So for example, say we have a question here. What are the main differences between polytechnics and community colleges in Malaysia? So a low comprehensive answer would be like, okay, the main differences is poly is this, CC is that, and then it's just in a few short words. That is what we call a low comprehensive answer. A high comprehensive answer will be like this, right? So you state out all the differences, and then you give examples, you elaborate, and then you talk about more information. So the idea is that you want your model to talk more, to elaborate when it's answering a question, right? Instead of just giving an answer that is flat. So how you can prepare? So it then goes back to your data set. How do you prepare your data set? Because remember, the main thing that is going to influence your model is two things. First, it's going to be your data set. Second is your hyperparameters. But more than hyperparameters, actually the most important thing is the data set. Essentially, is what you are feeding your model. What are you fine-tuning your model with, right? And that's the data set. So to give you a very good example, now, so when you have, earlier all of us, we uses party rock. So over here, you use something like this, right? So like over here, TVET, TVET policy, right? So this is something that that if you went through the workshop, if you have started preparing your own data set, you should be already familiar with this. So you see, you prepare the answer. But what you saw over here is that in this sample data set generator, the answer is quite short. You can see that what is the primary objective of TVET? And you can see that the answer is only about less than 50 words. The primary objective of TVET policy is to provide individuals, is actually less than 30 words. If you look at the other one, explain the importance of industry academia collaboration. So there's another question that's generated by dataset. But here you see again that the response can be quite short. The industry academia collaboration, is aligned to current and future needs. But altogether, you can see that it's less than about 40, 50 words. So the question is, how do you get the model to answer more? So if you train your model with just this kind of short answers, what you end up is that you get a model that doesn't talk a lot. You just get a question, you just answer at a very short range, right? So you want to get the model to answer more. How do you do that? Now, there's a few ways but the most easiest way is to use a synthetic data generator over here like this, right? To generate the data. So to give you an example, let's say we use something like one thing. So there's a lot of tools out there that is able to generate, that's able to essentially act like a dataset generator. There's like ChatGPT and all. So one of the tools they can use is Perplexity. It's free to use. You can access it. So I can ask you a question. Now I'm preparing a set of exam questions about TVET Malaysia policy. Generate 10 questions on TVET Malaysia policy for me in this JSON format. So if you look over here, each JSON should begin at a brand new line. Each response should be 50 words. So you can actually copy what is over here. So this is coming from my dataset generator. So this is actually what happens behind the scene when you are using the LOL data generator. Actually, what is happening behind the scene is that we are actually prompting the model with this. So you can actually take this and copy this, right? So that over here, I can just copy this. I can paste it to another tool. For example, over here, I can paste it in. So I can exactly word for word. So I cancel that. Let me show you again. I can just copy this, right? I can go back to Perplexity. I can paste it in. I can say that, okay, the topic generate, I can say TVET, Malaysia policy, right? And then I can replace here again. I can say this is TVET Malaysia policy. And then here I can say generate for me, say 5 rows, right? 5 questions. And here I can say, instead of 50 words, I can say, give me 300 words. Now let's see what's going to be the difference, right? I'm going to hit the prompt button. So now what's going to happen is that Perplexity is going to look at the latest kind of like TVET issues in Malaysia. It's going to crawl the data. And then you can see that over here, I got a question, but notice over here, the answer is a lot more elaborate. Let me give you a side-by-side comparison. So if I pull down the party rock example, and I just kind of like close that, and I put it side by side, right? So I put it side by side. So you can see over here is that I got the same question, right? Over here, explain the importance of the policy, but the answer is quite short, right? It's over here, just like that. But you can see over here, this is talking about, again, it's another question, but the answer is so much more longer. It's talking about the until 20, all this information, and actually it's pulling. So you can see if I compare this over to this one, which one is the more comprehensive answer? Obviously, it's the one on the left, right? The one on the left has a much more comprehensive answer. So one way that you can get your model to perform better when it comes to the win rate is to tune your model with more comprehensive responses, right? So you can use, of course, you can use Party Rock, you can create your own app, but one way is that you can just use other app generator to do that. So I can even say, I think all of us here, we are familiar with ChatGPT, right? Over here, I can take the same thing, I can copy, I can go to ChatGPT, I can just paste it in, not changing anything. I just copy and pasting the exact same prompt, right? I hit it, and let's see what ChatGPT gives me back. So here you can say that, oh, then it starts to begin to give me the data in the format, discuss the key objective, and then you can see that it starts to prompt out the response, right? And you can see it's quite detailed. It's talking quite a lot, and oh, there's quite a lot of words, right? So after that, and then after that, you just keep on going, right? So you can see that it's trying to create a very long answer. So to give you an example, let me just say go to Microsoft Words. Let's see if I just paste that in, right? So you can see over here, I have, let's say I take the second one. Just from here to here, in terms of the response, over here, it's about a total of, let's see, how can I see that, right? It's about a total of, let me enlarge that. So a total of, okay, actually, let's make this easier. I'm going to copy this. I'm going to go to a word counter, right? So if I paste that in, you can say it's actually 226 words. So it's a lot more comprehensive, right? If I go back to the Party Rock example, if I just take this and I just paste it in, it's only 34 words. So the answer is not that comprehensive. Or if I take this one and I copy and paste that in, you can see it's only about 31 words. Now, if I go back to the ChatGPT answer, you can see that if I take another one, the answer over here is a lot more comprehensive. It's about 175 words. Or if I go to, say, Perplexity, you can see that if I just copy this all the way up to the response part, which is this part is the response. If I copy this and if I paste this in the word counter, it's 206 words. So what I'm trying to say here is that essentially tune your model with not just more data rows, but data rows with more quality data. So you want quantity, but you also want quality data. And how do you get a quality data? Is that, remember, going back to the rubric, like what Akasha shared earlier, you want your answer to be accurate. Secondly, you want your answer to be comprehensive. And by comprehensive means you want your answer to elaborate. So most of us here, we are lecturers. Just imagine like your students submit like an essay, right? One student, they submit a short answer. The other one, they elaborate a lot more. So you're probably going to give a higher score to the student that submit a much more elaborated, comprehensive answer. So the same applies to the virtual leaderboard. All right. So so this is one way to improve your win rate, right? hot tip right there. So maybe we can see if there's any question from the ground. Akasha, do you want to read to me, or do I go to the YouTube site and pick it myself?
Already paste the 2 questions inside the Google Meet chat. So maybe.
Okay, we have one data set with high win rate. Then we upgrade that same data set and submit it to the leaderboard. But then the win rate is dropped. Why? Great question. So it can happen because of 2 things. So when you add data to the data set, right? Remember, at the end of the day, we are competing on these 5 domains. So it's a bit of trial and error. So when you're preparing when you're adding data to the data set, now, if you are adding data that's related to, wait, let me just go back to that policy. If you're adding data that's related to these topics, and first, it's going to be more valuable. Second thing is that, remember, under these topics, there are different questions. So one of the reasons why your win rate drop, it could be that you're adding in questions, but those questions are not very related to what is inside the leaderboard. So it may dilute the score of it may dilute the response of your model had you not add those questions in. That's number 1. And number 2, when you add those new rows in, it depends on the quality of those rows. So just now I mentioned about comprehensiveness, right? So if those rows you added in, maybe their answer is a lot more shorter, less comprehensive, they're less accurate. So you may end up getting a lower win rate. So think of it like an exam paper, right? Typically, if you think about exam paper, you have section A and section B, and then you got section C. So imagine a student do very well in section A, they get full marks. So up to section A, they are still at 100%, right? But let's say they attempt section B, but at section B they perform more poorer. They attempt more questions, right? But this will cause their overall score percentage to drop from 100% down to a lesser percentage. So what I'm trying to say here is that when you're adding data, it's not just about mindlessly adding more data and more data. It goes back to you want to add more data, but also more quality data. So what I'm trying to say is that, let's say you have 10,000 rows compared to 10,000 low quality rows as compared to 1,000 highly quality rows. The 1,000 highly quality rows is going to perform better as compared to the 10,000 rows whereby the answer is not so factual, not so accurate, or maybe less comprehensive, and they're not related to the questions domain at all. So this is one very often reason why your win rate will drop. So one of the tips is that, let's say you know that your win rate is getting you, say, 50%. What you want to do is to not immediately, let's say your data set, say you got like 500 rows, and you're getting like 50%. The good strategy is not to immediately add another 500 rows. You can attempt to add another 100, 200, just a small delta, and see how does that change your data set, how does that change your model performance. And then, let's say if it increased, you can continue to push on that, right? But if it doesn't, you can again change the data set and see what else you can add in to push the value. So again, try to make changes incrementally as well, instead of just big bang changes. Unless your original data set is already, or you're building your own first data set from scratch, and your original data set, the quality is not so good, then it's fine. You can prepare the first time, you can prepare a good enough. But if you already have a very good win rate, then a good strategy is not to make big and huge changes. You just add in delta changes and see how those adding delta changes is able to improve your model. That's why it's called model fine-tuning. So you want to adjust a little bit here, adjust a little bit there, see how the performance goes, then adjust a little bit there, adjust a little bit here to see how the performance changes. That's one of the key tips when you think about the concept of fine-tuning, right? You are doing fine adjustment, just like a very expert craftsman. All right. So that's to answer the other question. Now going back to the second question. The dataset itself must be single language or can be in both English and Malay. So yes, you can be in both English and Malay, right? So if you prepare your answer in English, what's going to happen is that your model will typically answer more in English. If you prepare your answer in Malay, what's going to happen is that your model, say given the same question, you respond in Malay. Now, which one is better? We never dictate the model to say English or Malay, which one is better. So this one is where you want to do a bit of trial and error. You could also try preparing a model. In fact, this is the first time we are doing LOL with bi-language. Often it's just one language. This is the first time we're doing bi-language. So one of the strategy that you can do is that you can prepare one model with a Malayu language and then one model with English, and then you can see which one perform better. So you can do a bit of trial and error. If the one in Bahasa, the one in Melayu does a lot better, then that would be a good obvious sign, right? But if the one in English is better, then you can try that. So this is something that as an organizer team, we will not tell you. Actually, we didn't try it ourselves as well. So this is something for everyone to experiment as you go about tuning your model. All right. And the other question is around what is the solution to algorithm error? We can't submit the data set because of it. So algorithm error can happen because of many reasons. So if you recall, Akasha and myself, we shared a checklist. So you definitely want to make sure that your checklist is correct. Just earlier this morning, I was helping one of the participant or team who is having an error. So give you a real example, right? So over here, I forgot we created a validate training data feature. So you can choose your data set. So over here, I'm going to choose one that is say the one that was actually from one of the participants. I think it's called, let's see what is it called again. It's called Train D. It's from group 250. So you can see that there's an error over here. So there's an error over here. So and when I begin to open it up, when I look at the error, I saw that. Let me just open up the where is that? Over here. So the error was because at the end of every sentence, he actually had a comma. So remember, by right, there should be no comma, right? There should just be, to give you an example, that actual one, a good data set should look a little bit like this, right? So it should look like, let me just open up one. So you can see the one over here that is valid, there's no comma. It opens with a bracket, it closes with a bracket, right? It's a valid JSON object. But when you look at this one over here, it opens with a bracket and it closes with a comma. So and this group, I think they may not know that there's this validate training data. So they
sorry to intervene. You forgot. I think Vincent, you forgot to share the screen, or you purposely just, or is it?
Oh, sorry, I didn't know that.
Okay.
Thanks for calling that out. Yeah. So let me just okay. Can you see my screen? I hope you can see. Yeah. So over here, so we added a new feature just for the POLYCC LOL. So you can validate training data set. So you can take a data set, and I actually in the morning I was helping one of the group 258, and then you can see that when I try to open it up, there's an error. It says that and you tell you at line 1 there's an unexpected white space at the end of the position, right? There is at line 1. So when I open up the data set, I downloaded it, I look at it. This was the original file at the bottom. You can see that every single line it had a comma. It had a comma, right? But if you look at the one that's above this, the sample data set, it opens with a bracket and it closes with a bracket, right? It opens with a bracket, it closes with a bracket. So what you want to make sure is that your data set, it needs to pass, first thing first. If it does not pass this validation data set, this is like just step 1, right? If it does not pass here, when you go to your training job, it's going to fail 100% because your data set is not in the correct format. For when you do fine tuning, your data set need to be in a certain format, and the format is what we have given to you as part of the sample data set. And so it needs to follow that format, which is essentially a JSON object. Every line is a JSON object, and every line needs to have the instruction, context, and response, right? So that's the first thing. So if you have algorithm error, oftentimes it's because of this. All right. So, but if you change the hyperparameters, but you overchange it, or you change something that you shouldn't have changed, that could cause another error. But over the last 1 week, as we are running the competition, most of the time when people have algorithm error, 9 out of 10 times is because the data set is not valid. Yeah, or they point to they point to a place where the data set path is not there. So you want to make sure that your data set is a valid JSON line file. All right. So going back to the that's the solution to the algorithm error. How much row on one data set is it 50 or more? You need to have at least 50 rows. But if you get 50, if you saw the sample data set that we provided, this was the sample data set, right? If you downloaded it as the guide, you see that there's 50 rows, right? So at the minimum, you need at least 50 rows. You can even take this and then you can add on top of it. So what I like to do is that, let's say over here, after you generate out your data set, right, you can copy this and go to the sample data set and just add to that, right? So you can add to that. So I can add to that. You can even combine data from multiple tools. Like this on ChatGPT, for example. Let's say if I go over here, I can take the ones from here. Let's say this one, right? I can take this, I can come over here, and I can paste it. So basically, you can just add on to your data set. Just keep on adding and adding and adding. And the minimal you need to have is 50 rows. So if you don't want to use the sample data set, you want to train, you want to prepare from scratch, then start with 50, or ideally it is like 100. That would be a good one to start with. So that is to answer the question: how much row on one data set? 50 or more. You should have at least 50. Okay, but more than 50. So we can say that performance in SageMaker didn't influence the win rate, right? As I get all the yes. So great question by Hafiz, right? So if I go to the training job, now let me just open up one. This is one of the teams to explain that in a bit more quick detail. So let me just open up to any random one, right? So this is not planned. Let's say I just open up to let's go to domain 1, right? Group 1. Okay. So let's say I just open group 1, and this is the same for any one of the teams out there. So if I open up group 1, when you go inside, you see of course the SageMaker jumps ID. Now when you go to the jobs, training job, so of course I see that team 1 has been hardworking, they've been training a lot of models, right? So let's say over here I train a demo model, right? Over here. So over here, you see that you get some basic what we call performance metrics. So eval loss, eval PPL, training loss. Now, over here, what this metric is referring to is nothing to do with the leaderboard. What this metric is referring to is that you have all this data, you have all your data. So remember, let's say I go back to, let's put it side by side. So it's easier to explain, right? Let me just put this side by side. So I put it here. So now imagine this is the data set that I fed to my training job. And I'm training my model, I'm fine-tuning my model on these 56 rows over here. Now, what's happening? What this performance metric is telling me is that when the GPU is tuning your model to a data set, it's like the oven example, right? It's telling you how good the model is tuning to your data. So the idea is that the lower the number, the better it is. So let's say you get like 0.9, let's say this is 0.998. If you get, say, like 0.878, now 0.878 is smaller than 0.998, right? So if you get a smaller number, what this means that your error rate is lower. What happens is that typically when you're doing a model AI tuning or training, your model will take your data set, and what you do is that you try to learn your data. And when you try to learn your data, every now and then it will test itself. Does it remember your data? And when it checks and when it tests itself and then when it sees how much error it has against what the model is trained on, then it start to generate the error rate. So again, to answer the question, the metrics over here simply tells you how good you have configured your hyperparameter, which is actually talking about what is over here. It's not talking about how good your data set is. So let's say you have 1,000 data sets. And let's say they are of poor quality, low quality data. So you can get, but let's say when you're doing your training job, but your hyperparameter is set nicely, right? And then your performance over here is low. So what it's telling you is that your training job is tuning very, very well to your data set. Now, it tunes very well to your data set, but it doesn't mean that it can do very, very well on the leaderboard. Right? It's simply just telling you how good the oven is at cooking a recipe. So I like to give this other analogy typically when I teach in university, right? So imagine you have an oven, and then you prepare you want to cook a chicken, right? Ayam dish, you're baking. So you can prepare the dish and then put it into the oven. And of course, the oven, you need to configure the oven, and then after you cook it, right? So you can you can configure the oven very well, everything is perfect. And then after that, the chicken comes out, the cooked meal. But the end result may not be tasty, right? If the recipe itself is bad, all right? If let's say the chicken itself, the ingredient, the quality of the chicken, the marinade, the ingredients that goes, or the recipe that goes into preparing the chicken before it goes into the oven, if it's poor in the first place, then even if your oven, you get the best oven, you have the best timing configuration, you bake it just the right amount of time, you're not going to get a very outstanding dish. You're still going to get a not so outstanding dish, right? So you can see there's two elements over here. The first element is your data set, and the second element is your hyperparameters. So the performance over here, it tells you more about your hyperparameters and not so much about how good your data set is. That one is something that you got to submit to the leaderboard, and then from there you get a win rate. All right, just that to help to peel the onion a bit, to explain a bit more behind the metrics over here. But it's good to know. So you know that, say if you got very, very good data set, but if let's say the performance metric is a bit high, it's like 2.2 instead of 0.9, then it means that, okay, maybe your hyperparameters, you might want to adjust a bit. You might want to adjust the learning rate a bit. You might want to adjust the epoch a bit so that you can learn better. And if you learn better, you'll see that the error rate here should go down more as compared to a high number. All right. So that's to explain the performance metric that you see at the training job. Okay, back to the messages. How to make a whole topic into one data set. So you just saw that, right? So you prepare the data set, say over here with Perplexity, with ChatGPT, or say with with PartyRock, and you basically just add them all into the rows, right? So basically, all you need is just one data set. I mean, just one single file, and you can add all of them into one file. So you don't need to have 10 files. You can just have one file, and just every file, you can have line 1 to 100. That could be the subtopic 1. Line 101 to line 200. That could be your subtopic 2. You don't need to have many, many files. All you need to have is just one file. So to give an example, a sneak preview of when we did one of the customer competition with a bank. This was one of the top model that they had. So you can see that if I open it up, they had I will not show you the full thing, but they actually trained with 30,000 rows. All right, they trained with 30,000 rows, and it's just one single file, and they trained a very, very good model on Vietnam banking regulations with just one single JSON file. Right, so all you need is just one file and put all your data set inside. But how you want to arrange it, it's up to you. Okay. Now going back to the model, I mean to the questions. So if I make a data set, how the accuracy comes from? Do I search it on Google or any search engine? So you saw the example earlier. How do you can prepare a data set through manual means, but that's normally a bit more heavy-handed. A more easier way is to use something like you can use PartyRock, just like you saw earlier already. You can use a PartyRock generator. Also keep the PartyRock generator, you can actually remix it. You can create a copy of it. So I can create a copy of it. So this is something I can remix it. So after you create a copy, it's like you clone the app. After you clone the app already, you can actually go to here, and you can actually change the prompt template. So you can see over here, I can actually change it to say like instead of 50 words, I can change it to like 150 words. So let's say I save it. Let's say TVET policy, say 5 rows, and then if you look over here, you can see that now it should probably generate a slightly longer answer, right? So you can see now it talks more. So as compared to the previous one where there's 20 words. So if I copy this and I go to my word counter, right, you can see it's like 83 words instead of 27 words. So it elaborates a bit more. So you can use PartyRock. You can clone the original. You can remix the original dataset generator. You can remix it. Any PartyRock is free. You can just remix it, and just change the prompt template, and then just generate more data in different style. You can use things like Perplexity. Perplexity is a very good tool. It's like think of it like it's like your ChatGPT, but with a very, very good web crawler. So it's able to, when it's generating the question, it actually look up online sources. Like these are online sources that they pulls up, and then from there on, it generates out the answer. Right? Of course, you can use ChatGPT. You can use other any kind of large language model, generative AI tools to generate the data. All right. Now back to this one. So we answered this already. Why I feel on part 2 is that the endpoint don't exist. Even after I already create endpoint in part 1 evaluation. This can happen. I mean, this doesn't tell me much. It can happen because of a few reasons. It can be that your evaluation data set is not of the right format. So one of the common reasons is that if I go to the show you, your evaluation data set is in this format, right? So I have given you 2 data set. One is in this one. So this is your training data. The other one is your evaluation data, right? So let me just put this side by side. How do I put this up? Let's see. Okay, let me split the screen. Split down, right? So if you see this, okay. So let me just close that. Now, if you look at this one, this is my training data set. You can see that the format is instruction, context, response, right? So it's a JSON object. So if I take this, if I go into a JSON editor, right? So you can see that it has instruction, it has context, and it has response. This is the format required for doing tuning. But if you look at the evaluation data set, you see that the format is slightly different. So it has model input followed by target output, right? So if I have to paste this in, now if I have to validate, you can see that the key value of this one is slightly different. It's still quite similar, but the key is different. One is model input, and the response should be target output. So your evaluation data set, it has to be in this format. So if it's not in this format, then what you're going to end up with is you're going to get the same problem as tuning. Your model is trying to evaluate, or rather the SageMaker job is trying to evaluate your model, but it cannot process your evaluation data set, right? So that's one of the main common reason why your evaluation will fail, right? So the other thing is that your endpoint needs to be deployed. So after you deploy the endpoint already, then you run your evaluation data set. So there's 2 things, right? One is your endpoint could be up. Second thing, your evaluation data set, it has to be in the correct format. So far, we don't have we do have a validation for evaluation data set, but that's something that you can try to add on later on. But for now, you got to do it. You got to check your data set yourself. We only have validation for training data set. All right. So going back to the question. Now, how does learning rate and epoch improves training? For example, if I'm using data set with different learning rate and epoch setting, does that improve the training? So we have explained that already in the YouTube. If you're asking this question, it means that you probably might have missed the original YouTube recording. So you can look at that. I actually covered that in this section. So you can fast forward that to here. So I'll not go through that because we only have 10 minutes, so we can cover more questions. But in the workshop, I covered, I have 2 slides where I talk about epoch and I talk about learning rate. And I talk about the pros and cons behind a high learning rate vs a low learning rate, and as well as a high epoch versus a low epoch. So you can look at the recording over at the YouTube channel. All right, so that is to answer that question. Now, the next question, what are we comparing our AI output to? Are we measuring it against the target output and ideal output or another AI output? Yes, so this again, we have mentioned that before in the workshop. You are competing against this model, right? So essentially, let me see, do I have that here? No, do I have that record? Okay, I do have the picture. Let me see. Let's see if I have that picture. So, okay, let me just stop my sharing for a while. And let me show you that picture that I was referring to. So essentially, when you're submitting the model, you are comparing against a reference model, a bigger model. And the bigger model it looks a little bit like this. Let me just pull that out. There we go. Okay. Let me share my screen again. So over here, so essentially what you're doing is that you are training a llama, actually 8B, right? And you're trying to defeat a llama that is 70B, a much more bigger model, right? And when you submit the model to a leaderboard, let me just put this side by side again. Over here, let me just make it a bit smaller. And let me open up the LOL console, right? What's exactly happening is that, okay, let me just put it in. Let me go to the leaderboard console, right? So when you submit your model to a leaderboard, what's happening is that your model answer, so let's say I take, for example, POLYCC, for example, right? So when you submit the model to a leaderboard, what's going to happen is that about 49 questions will be generated against your model, against your fine-tuned model. And when you submit the model, what's going to happen is that these 49 questions, there's already a reference output, right, which is produced by the Llama 70B, the much more bigger model. And by default, at the start, as you can imagine, a small model will, in the same model family, and these are the same, these are both Llama models, right? They're not different model. They are in the same family tree. So a big one will always beat the smaller one if it's the same, if everything else being equal. But over here, the idea is that when you tune your model and you submit the model, your llama, it starts to evolve, right? It starts to go from like level 1 to level 2 to level 3 to level 4 to level 5 to level 6 to level 7 to level 8. You start to tune your model to become a much more stronger model until eventually you can defeat even though you are a small model, but you can KO, you can knock out a much more bigger model through the power of your fine-tuning. All right, so that is to answer that question. Back to the question, we have 6 more minutes. Is it better to increase the data set size for a specific topic? Are we aiming to deepen the AI's understanding, or simply to provide more examples for you to learn? Now, the idea is that your AI is already quite smart to begin with. It's not a dumb model. It's really quite smart. 8 billion parameters is quite good to begin with. It's just that it's not as good as a 70 billion model that's 9 times bigger. So when you are preparing a data set, essentially you're trying to augment your AI with more knowledge by stuffing it with more data set, but tuning it with more data, with more quality data. So when it's an 8 billion model, is up to this certain level of strength, right? But when you begin to prepare data with a lot more quality and of good comprehensiveness and accuracy, essentially you're helping the AI to, yes, deepen the understanding in that specific domain, in TVET essentially. But also not just deepening the understanding, but also allowing it to be able to answer the way you want it to answer when based on how you're tuning the model. So when you're giving the model all these like questions and answer examples over here, like this one over here, essentially you're trying to get the model to say, model, I want you to answer, next time when you see a question that look like this, right? I want you to be able to answer in a way that looks like this. So essentially, that's what you're trying to tell your model. It's like doing tuition to your model, right? So that's where your data set comes in, and that's where your data set becomes very important. It's not just about having more data. It's about having data that's of good quality, that's relevant, that's comprehensive, such that when the model is answering a question, now with this added fine tuning that's done on the brain, it's now able to answer much more in a much more better fashion. That's aligned to how you have tuned it. All right. So that's to answer that question. Okay, let me just go very, very fast. Right? Do duplicated JSON line make data win rate drop? Yes or no? When you duplicate the JSON line, basically it's like increasing the epoch. So remember what is epoch? Epoch is how many times your model will go through the data set. Let's say when you set, to give you an example, right? Now, if I have this over here, this is like the data set. Now I can take that, I can copy and I can paste, right? So I can paste it and then I basically got 112 data. This is the same as setting epoch to 2. Because remember what is epoch? Epoch is how many times the GPU will go through your data set in terms of repetition. You go through it one time, you go through it another time. You set it to epoch to 2. You set the epoch to 4, you go through it one time, go through it a second time, go through it a third time, and then go through it a fourth time. So if you duplicate your data set, basically you are trying to increase epochs, so to speak, right, manually. All right. Can we create a different line for each topic? Yes, of course you can, right? I've explained that. Okay, eval loss, is it good? 0.5 is good, actually. Actually, it's really good. Sometimes you saw the examples that I gave you earlier. If your eval loss is 0.5, your training loss is 0.5, as you compare to this one, you can see your performance metric is actually half of what's over here. So that means that your hyperparameters configuration is pretty good. You are actually tuning quite well to what is the data set over there. So the lower, essentially the lower you get, the better it is, right? So one reference is that you can look at what is the sample performance metric and try to get it lower. And this is normally influenced by your hyperparameter, right? Also, does training accumulate over time? Being once the AI is trained, does it retain and build on? Normally you can, but using the tool over here, we always retrain from scratch. So normally in the real world, in the production setting, you can do that. But specifically with SageMaker Jumpstart right now, you can, every time you do tuning, you are tuning from scratch. But this is a feature that is actually as part of the roadmap feature for Jumpstart, but it's not going to be ready for this competition, right? So, but in the actual setting out there, there's two ways. You can tune it again from scratch each time. Secondly, you can tune it after you can tune it some more, you can tune it some more, you can tune it some more, right? So there's pros and cons to both aspects. Pros and cons to the upside to tuning from scratch this time is that you're always starting from a clean state, right? But if you tune it continuously, say if your first tuning is bad, is terrible, then your error will be carried forward to the next tuning. And then it's already ingrained inside your data. You can't erase it. So one of the very good thing about tuning from scratch this time is that you're always starting from a blank canvas. All right. How does the win rate work? So I already explained that it is by comparing against your reference answer. Okay, perfect. I think I managed to run through all the questions, and I'll hand the time back to Akasha to maybe close off.
Okay, terima kasih. Thank you very much, Mr. Vincent, for your explanation on the how to win the POLYCC LOL 2024. So I'm sure all the participants get the understanding of what have been explained by Mr. Vincent. So maybe I think the times is running out. Okay. So sekarang ini kita dah masa berlalu begitu cepat. So saya rasa soalan-soalan yang akan datang boleh boleh terus ditanya dalam grup WhatsApp ataupun grup Telegram. I'm sure Mr. Vincent dan saya juga cubalah menjawab soalan-soalan yang basic, dan Mr. Kwan, Mr. Aswin akan bantu anda semua. Okey, jadi saya harap pesyarah semua yang hadir pada sesi pada petang ni ya mengambil manfaat yang besar daripada sesi ini. Jadi pertandingan POLYCC LOL ni bukan sahaja untuk kita berpeluang untuk bertanding lah, tapi juga satu platform untuk kita mendalami ilmu dalam membangunkan model LLM. So ilmu yang kita dapat hari ni mungkin adalah ilmu yang the latest lah. Sebab kita pertandingan LOL 2024 ni adalah yang kali pertama di Malaysia. So orang lain tak buat lagi. So maybe benda ni susah nak faham. It's hard to understand, Vincent. So I think this is a good chance for all POLYCC lecturers and students to get this opportunity to learn how to develop LLM, because we still not very hot lagi. Topic is not very hot. Once it's hot topic, then use it is too late. So we are in the first in line in getting the knowledge. So saya harap semua dapat ambil peluang ni, dan juga Jangan orang kata mudah putus asa lah kalau tak dapat login. Sebab Mr. Vincent juga dah sediakan PDF, dah sediakan PowerPoint dan dah sediakan recording YouTube untuk part 1, part 2. Cuma kena tengok je. Dan juga saya pun ada sediakan YouTube tutorial lah. Mr. Vincent, I also make some short videos so to help some of the students and participants on how to log in
That's
the
good. Very
yeah
good. Great
AWS
to
Sesame because sometimes likes to watch, some people like to read, some people likes to look at the pictures. So I'm sure all of you make sure you take this opportunity to learn LLM. Dan juga sekali lagi saya terima kasih kepada Encik Vincent selaku penceramah utama daripada AWS Singapore, Encik Kuan dan Encik Aswin yang turut online pada petang ni daripada AWS Malaysia. Dan juga kita ada Dr. Zura ataupun Puan Siti Noridah selaku director lah, the director of this program pertandingan LOL 2024, dan juga Puan Mazlin yang juga hadir bagi support kepada saya, bos saya dalam menjayakan program ni. So I think that's all for today. So kalau ada apa-apa soalan, terus bertanya jangan segan saya nampak macam jangan segan bertanya dalam grup, sebab bila bertanya dalam grup nanti ada partisipan yang boleh share lah. Sharing is caring. Okay.